Hi, my name is Kamran and welcome to Anfaq Cloud. In this demo session, I am going to show you the how you can quickly set up VPC with and its component with Terraform official provided VPC module. So let's just dive in. So here you can see I have my IDE open and I have written a Terraform VPC module. So basically what this module is doing, it has a main file which is just using the official Terraform module, and I have written some parameters to pass in, for example private subnets or public subnets, and some VPC name. So this is just a simple module which is just calling the Terraform official module and taking parameters or inputs from separate directory. I will show you later. So this module has also been published onto my GitHub channel, and you can see my repository here, Terraform AWS VPC, and this is just calling the official Terraform module. And here you can see I have written some linting files for pre-commit, and my module is ready to be used. So this is the module, and it is outputting some IDs, for example cider or VPC ID in private subnets, public subnets IDs, and it has a variable file, and I will pass some inputs to this module. So let's check out now the calling repository which is calling this module, Terraform AWS VPC. So I have written a Terraform live demo. This is called calling repository or infra repository, or you can say it live repository. So here again I have some blending files, and I also have this main file, and in the main file you can see I am referencing my module Terraform AWS VPC on my GitHub repository, and these are some inputs variable which I needs to pass, and I have written the values in the locals.tf file. So let's check on locals.tf what we have in that. So this is the region I'm specifying, in which region I want to deploy my VPC and its components. The service name, basically I have used this service name because in the next demo I will be showing why I am creating this VPC. So the next thing is CIDRs, private subnets, public subnets, and the AZs I want to use, and I have also configured the VPC name. So let's also check how I have calculated this CIDR range. So basically I have used 172 range CIDR with slash 22, and I have used this tool called Subnet Calculator. So what you can do, you can choose any IP range. So I have used 172, and I have set it to 22. So my network bits are 22, and the rest of remaining bits are host. Here you can see, and here in this section address per subnet you can see how many IPs I am getting. I am getting 1022 IPs with these slash 22 range. So now I want to do subnetting, and I need to have private subnets, 3 private subnets, and 3 public subnets. So what I'm going to do, I'm going to turn on one bit, so it shows I will get 2 subnets, and if I turn one bit on, one more, so I will get 4 subnets. So what I am gonna do, and it is showing you the subnets and the start address, end address, and also the network and broadcast address. What I'm gonna do, I'm gonna use these first 3 subnets as my private subnets, because most of our workloads remain in the private subnets, not in public subnets, right? So in the third subnet, I'm going to create multiple subnets in these subnets, so subnets within subnets, so that I will not waste my IPs. So as you can see here in my code, I have used the private subnets, which is showing me here first, second, and third, 0, 1, and 2. So 0, 1, and 2 as private subnets, and what I have done, I have copied these range and paste it again here. So now my subnet mask bit is 24, and if I turn on my bits, so each subnet I'm getting 254 IPs, but these subnets I want to do further classification. So for public subnet I need again 3 subnets, and if I will turn on these subnets number of bits 2, I will get 4 subnets. Again my one subnet will gonna be waste, but it's fine. So each public subnet will get 62 IPs, and each private subnets will get 254 IPs. So you can see it has provided me range of the subnets, and I have used those in as public subnets. So 30, 364, 3128, you can see that, and this subnet is gonna just waste as it is. And I have used 3 availability zones as in region EU West 1A, EU West 1B, and EU West 1C. So before deploying our module, very quickly I want to show you what I have configured in the VPC module. So as I have told you that this module is just using the Terraform official module. But here you can see I have enabled some settings. So this is called single NAT gateway. What I am saying here is I want to use only one NAT gateway for each of my availability zones. I do not want to have NAT gateway for each availability zones or for each um, subnets. So this is what I am saying here, and you can also read the documentation on the Terraform official module. So this is their official module, and here you can see they have provided the NAT gateway scenarios. So by default behavior is you can enable NAT gateway, and it will deploy NAT gateway per subnet. So if I have 3 subnets, it will deploy 3 NAT gateways, and NAT gateways obviously have high cost. So to avoid that, I am using this scenario, single NAT gateway. So what is this single NAT gateway? True, and enable NAT gateway true, and it will gonna create single NAT gateway in one of our public subnet in first availability zone, first provided availability zones. And also they have other option, one NAT gateway per availability zones, which is again same if you are using 4 availability zones, 5 availability zones, depending on the region. So it will deploy NAT gateway per AZ. So let's quickly jump to our IDE again and deploy our module. So this is my module code, and this is my live repository, which is just calling this module with some local parameters. I'm going to open my terminal, and I am here in live demo, which is fine. So now I am going to run Terraform init, which is just initializing the backend. Then I will validate the code, which is showing success, and then I'm going to run my plan, Terraform plan. So TF is just an alias for Terraform. So it is showing me 23 to add, 0 to change, and 0 to destroy. So let's see what it is doing. So it is just creating this default network ACL. So I have just provided some tags so that I can recognize my resources. So network ACL default is going to deploy, default route table is going to deploy, default security group is going to deploy. So here comes our EIP. So when we deploy NAT gateway, so it attaches the elastic IP on that NAT gateway, and we also have the internet gateway one NAT gateway, and it is creating a route to NAT gateway, and it is also creating a route to internet gateway. And then we have one route table private, one route table public, and these are the associations of subnets with route tables. And here you can see we have private subnets, so in EU West 1A, in EU West 1B, and then EU West 1C, so three private subnets, and three public subnets again in same availability zones, West 1A, 1B, 1C. And this is the VPC with our CIDR range. So let's just deploy our code. Terraform apply. So basically, to deploy Terraform code in AWS account, so you have to provide a provider. So I have written the provider, and the region I am using is EU West 1, and I have set up my access keys in my AWS config, so that's why I am able to run Terraform on my local machine using the credentials for my AWS account. So meanwhile it is creating our resources, let's just check out what it is creating. I have created a diagram, and let's see this diagram. So basically we have an AWS account, and in AWS account we have a region which is EU West 1, and then we have in region VPC, and in VPC I have used the three availability zones, 1A, 1B, and 1C, you can see. And in each availability zones we have public and private subnets, so this is public, this is private, and same here in AZ1B and in AZ1C. And each of these public subnets here, they are attached to public route table, and here the private subnets, they are attached to public route table. And as in our plan we saw that Terraform is going to create a public route table and a private route table, and it will associate private subnets with private route table and public subnets with public route table. And if we will see when our deployment is done, then we can see in our public route table we will see two routes. So this is our VPC CIDR, and this route is just saying that traffic will be this traffic range, within this range will be inside local, and everything else is going to internet gateway, so because this is public route table. And in the private route table we will see that this traffic on the VPC CIDR will remains local, and everything else will goes to NAT gateway. And here you can see the NAT gateway. So as I have told you, to save the cost, I do not want to use NAT gateway per availability zones or per subnet. I want to have single NAT gateway, so that's why you can see our NAT gateway in public subnet. And why it is in EU West 1, because by default it will deploy the NAT gateway in the AZ, which is first in the list. So in the code you can see our AZ list, and the first AZ is EU West 1A, so that's why it's deployed in EU West 1A. And this workload is just an example. So in private subnets maybe we will have our workloads running here. So this is what gonna happen when our deployment will be done. So let's just check out our deployment. So yeah, 23 resources added. Going to my account, so this is my account, and here you can see I have VPC, and let's just check out the subnets of this VPC, and ID is 90F. It has not updated. Let's just refresh. So yeah, 90F. So we have three public subnets and three private subnets. Let's just check on the route tables, and let's just filter out with our VPC 90F. So you can see we have a default route table, public route table, and a private route table, and three subnets are associated with public and three subnets are associated with private. So let's just check the public routes. So as I have said you that default local VPC traffic will gonna be remains local. One one is that route, and everything else is going to internet gateway, because we have this internet gateway also attached with our VPC. So this is the public route table. Let's just check to our private route table. So here you can see again the VPC traffic will gonna remains local, and everything else will gonna goes to NAT gateway. And if we will see our, so this is our internet gateway, and if we will go to NAT gateway we will have, okay, so one was deleted because I was doing experiment, but you can see here this is our NAT gateway, and it is created in our VPC, and the subnet is public EU West 1A. So as I told you here, public EU West 1A, which is first in the list. So yeah, this is the VPC and its components. You can directly use my module to create this kind of setup, and I have published all of my code to my GitHub repositories. Feel free to download and test and play with it. Thanks for watching. So basically I'm building this module because I'm going to show you in future about TFC agents. So the purpose of creating the VPC is to have TFC agents in this VPC, and I will show you how Terraform agents work, and about Terraform Cloud, and how we can have deployments in multiple AWS accounts using Terraform agents. So stay tuned, keep updated. Thanks for watching.